Hi everyone, welcome to another episode of Don't Be Average. In this video, I will show you how to build a linear regression model and make predictions using Python. Python is becoming like a one-stop solution for all kinds of machine learning and data science related problems. Majority of the companies who are hiring data scientists look for people who have built models on Python. So even if you know how to do things using other programming languages like R, MATLAB or something else, it is good to also try your hands on Python. In today's video, I'm going to use Jupyter Notebook IDE, but you can use anything of your choice. The method and the codes will not vary. So without further delay, let's jump.
It's only worth it if you work for it. I won't stop till they hear me now. I won't stop till I wear the crown.
I have opened up a Jupyter notebook. The first thing we will do is we will import the packages and classes. We need 3 packages for this. The first one is pandas. This package is needed to load the input data. Then we will import NumPy. Why do we need NumPy? It is because we need to convert our data into arrays before we pass it for model building. NumPy is a package that can convert something into arrays. The last and most important package that we need is sklearn. Sklearn package contains a class called Linear Regression that can be used to perform linear and polynomial regression and make predictions. The next step is loading the data. Like I said, I'm going to use pandas library for this. I'm giving a name for the data as dataset. So I will write dataset equals pd.read_csv open close bracket as of now. This is the command to load a CSV file into Python environment and store it as a pandas data frame. Inside this open close bracket, we need to put the path of the CSV file. I have saved the data in CSV in the same path where I have opened this Jupyter notebook. So I'm going to put the name of the input file. You can also put the complete absolute path if you want. To see the data, you can just write dataset now. And now you can see the input data. Here we have age, we have number of hours spent per week on exercise, and we have weight loss. Weight loss is our dependent variable. We are trying to predict weight loss based on age and exercise. So our regression equation will be weight loss equals a plus b1 into age plus b2 into exercise. So like we all know, the equation of linear regression has a standard form of y equals to a plus bx, where y is dependent and x is the set of independent variables. So our x would be the columns age and exercise, and y would be the column weight loss. So far we have a data frame x and a series y, but we need them as arrays. So we convert them into NumPy arrays. Once we do this, x will become a 2-dimensional array and y will become 1-dimensional array. If you want to see x and y, you can just type their variable name and run that cell. You should be able to see that they are converted to arrays now. The next step is to create a linear regression model and fit it using the existing data. So first we are creating an instance of the class linear regression, which will represent the regression model, and then using .fit and passing our existing data x and y, we are actually building the models and also estimating the coefficients a and b using this set of data. Now that we have a model, we would see how accurate is this model. To do that, we have a method called score. This will give you the value of r square or the coefficient of determination for this model. Our r square has come out to be 0.86, which means it is a good model and we can go ahead with this model. Next thing we would want to know is the values of the coefficients a and b so that we can estimate the equation. To find that, we need to use the methods intercept and coef. So model.intercept underscore will give us the value of a, which is 0.71. Next thing is b1 and b2. To get that, we need to use model.coef underscore. Our b1 is minus 0.03 and b2 is 0.54. Model.coef underscore gives us a list containing b1 and b2. If you want, you can also separate them like this. Our intercept value, which is a, is 0.71 and our coefficient for age variable is minus 0.03, and the coefficient for exercise variable is 0.54. Now I'll tell you what it means. First let's start with the intercept. Intercept value is 0.71, means that if you keep all the other variables at 0, you will get this much weight loss. Okay, in our scenario, since we also have age variable, it is not much interpretable. But if we had only exercise variable, in that case we would have said, okay, if you do not exercise at all, then this would be the amount of weight loss you would have got. And in the previous example that we have done, while I was explaining the concept of linear regression, we have seen that it generally comes out to be a negative value, which means that if you do not exercise at all, your weight loss may be negative, means you will gain a little bit weight. So that is the interpretation for the intercept. Intercept means if you keep everything else at 0, how much will be the value of your dependent variable. The next one is the coefficients b1 and b2. We'll start with b1. b1 is the coefficient of age variable, and b1's estimated value has come out to be minus 0.03. Now what does this mean? This means that if you are a 50-year-old person, you are doing 10 hours of exercise, and the amount of weight loss you will have will be a little lesser than if you would have been a 30-year-old person. That is the interpretation of the coefficient of age. Now the next and very important coefficient for our use case is the exercise variable. So for exercise variable, the coefficient is b2. The estimated value of b2 is 0.54, which is a positive value, and it is also not a small value, which implies that if you do work out, you're going to lose weight. Okay, so now we have built the model and we have seen the estimated coefficients. Next thing we need to do is predict the weight loss for some age and exercise duration. I want to predict how much weight loss will happen if a 20-year-old person does workout for 10 hours a week versus a 45-year-old person does the same amount of workout. Now let's see how much weight loss will happen in these two cases. We will use the method predict for this. As you can see, we got 5.48 and 4.62, which means 20-year-old person will lose 5.5 kg weight and a 45-year-old person will lose 4.5 kg weight if both are working out for 10 hours per week. So that is how you can build multiple linear regression models using Python and sklearn. Thanks for watching. See you in the next video. Until then, take care and don't be average.